And welcome to a revision video on differentiation for the Edexcel Core 3 Maths A-Level course. In this video I'm going to do the questions from 2003 to 2010 that have come up in regards to simple differentiation. This is just when you're asked to differentiate a function, not when you're asked to find a turning point of a function or a maximum or minimum or anything of that nature, or a tangent or a normal, just simply when you are asked to find dy by dx. Let's start straight away. As always with these, try the exam question and then check your work against mine. Do note how I write it. It's very important that you write it in the same style as I'm writing it. Right, let's start. Okay, this was a question from the Specimen paper and it asked you to differentiate various things. Let's start with each part. Differentiate with respect to x. I would always, obviously, just call the function something like y. Y is x cubed e to the power of 3x. You should spot straight away that this is a product, u times v. Okay, and you should realise straight away that's your u, that's your v, and you should use the product rule, which is not given to you in the exam, and dy by dx is uv dash plus vu dash. Okay, write down what your u is. Your u is x cubed, so that would make the derivative u dash 3x squared. Your v is e to the 3x, and so your v dash would be the derivative of 3x e to the 3x. Then just substitute in your dy by dx. dy by dx, therefore using the product rule, is uv dash, so x cubed 3e to the 3x. I'm going to write that as 3x cubed e to the 3x, plus vu dash, so that would be plus 3x squared e to the 3x. Could you factorise anything? Well, you could factorise out a 3. You could factorise out x squared, and you could factorise out an e to the x, and you'd be left with x plus 1. And there is your dy by dx. Next part, differentiate this. You should realise this is a quotient, u divided by v, so u and v. So if this function, if you had let that be y, then by the quotient rule, dy by dx is given by this formula, vu dash minus uv dash all over v squared. That is given to you in your formula booklet. State your u and your v. Your u is 2x, so your u dash is 2. Your v is cos x, so the derivative of cos x, v dash, is negative sine x. Now just substitute in to this formula. Dy by dx is therefore vu dash, so cos x times 2, so 2 cos x, subtract uv dash, so 2x multiplied by negative sine x, so that would be 2x and then negative sine x, all divided by v squared, which would be cos squared x. So let's tidy this up a little bit. Dy by dx is therefore 2 cos x. That minus multiplies by that minus becomes a positive, so positive 2x sine x, all divided by cos squared x. And there's no need to simplify it anymore. It hasn't asked us to. There is our answer. Next, part 3, differentiate the following. Well, I would first of all write that as y is equal. Now, tan squared x means the function tan x all squared. You should remember, if you have a function of the form f of x to the power of n and you differentiate it by the chain rule, you can bring down the power of n, you multiply by the differential of the expression in the brackets f dashed x, and you reduce the power of f of x by 1, f of x to the n minus 1. We can apply that here. Dy by dx is therefore, bring down the 2, The differential of tan x, you should know, is sec squared x. That's given in the formula booklet. And reduce the power of this by 1, it would just be tan x. So tidying up, dy by dx is 2 sec squared x tan x. And you're done. There's the differential. Okay, next, part 4. You're given that x is cos of y squared. Find dy by dx in terms of y. Couple of things to notice here, just before we launch into it. X is the subject of the formula. Okay, so we may end up using the dx by dy rule, i.e. that dy by dx is equal to 1 over dx by dy. That's where we've seen that coming up, where we want to find dy by dx, but x is the subject of the formula. The other thing to notice is that it says x is cos of y squared. That means the y is squared. It is not cos y all squared. If it was, it would have a bracket around it like that, or it would be written as cos squared y. So it is cos of y squared. Okay, let's have a go. If x is equal to cos, I'm going to put a bracket around it, I think it's safer like that, y squared, you can differentiate both sides with respect to y. Differentiating x with respect to y, you get dx by dy. Differentiating this by the chain rule, well, you differentiate what's in the brackets with respect to y, and you get 2y. You differentiate the cos, and you get negative sine, and of the function that it was, y squared. So therefore, tidying up, you get negative 2y sine of y squared. That is your dx by dy. But it asks for dy by dx, so the flip of this, so dy by dx, or the reciprocal of this, is 1 over, is negative 1 over 2y sine of y squared. And that's it, you're done. Let's move on to the next exam question. Pause the video, have a go. This was from June 06. Okay, go through each part bit by bit. I'll start at 2 part A. Differentiate with respect to x. Well, first of all, you should notice there's a function of x. And this here is a function of x. So it's a product rule where that's u and that's v. So your u is e to the 3x. Therefore, your u dash is 3e to the 3x. Your v is sine x plus 2 cos x. So your v dash, the differential of this, would be cos x, negative 2 sine x, negative 2 sine x. And you know also that dy by dx by the product rule, this isn't given to you in the formula booklet, is uv dash plus vu dash. Now it's just a substitution detail. So if y is equal to this, dy by dx is uv dash. So u is e to the 3x multiplied by cos x negative 2 sine x, and plus vu dash, well, v is plus sine of x plus 2 cos of x multiplied by u dash, which is 3e to the 3x. Okay, probably should tidy it up. Let's factorise out an e to the 3x. We'd be left with here cos of x subtract 2 sine of x. What would we be left with here? Would just be careful here. Do remember you've got a 3 as a factor in there. So you would have a plus 3 sine x, and you would have a plus 6 cos x. And now you can really tidy that up. E to the 3x, cos x plus 6 cos x is 7 cos x. And negative 2x plus 3 sine x is just a plus a single sine x. So your dy by dx is e to the 3x, 7 cos x plus sine x. Okay, moving on to part B, we want to differentiate this. Again, we have a product. There's our u. This is our v. So u and v. So if u is x cubed, u dashed is 3x squared. And if v is ln 5x plus 2, or the derivative of a ln of a function is the derivative of the function, which is 5, over the original function, which is 5x plus 2. You know that dy by dx by the product rule is uv dash plus vu dash. And so substituting in, if this was our y is equal to this, then dy by dx must be equal to uv dash, so x cubed, v dash is 5 over 5x plus 2, plus vu dash, so plus ln of 5x plus 2 multiplied by u dash, which is 3x squared. Okay, so just trying to tidy this up. Here we would have 5x cubed over 5x plus 2, and here we would probably bring this to the front, and it would be 3x squared ln of 5x plus 2. There's no point in tidying up any more than that. That is absolutely fine. Okay, next, part B here, we're only going to do part B. So part B says, given that y is equal to this, show that dy by dx is equal to this. Well, how could we go about by doing this? Well, what we could do is we could probably try and factorise to start with. Just see if you could factorise 3x squared plus 6x, subtract 7. Just see if that could be factorised. Could it be factorised as 3x and something there? Well, the only things that times to 7 are 7 and 1, so there's nothing really that works there, so we can't factorise. So therefore, our only option now is to think of this as a u divided by a v. It's of the form u over v, where u is 3x squared plus 6x subtract 7, where u dash would therefore be the derivative of this, which is 6x plus 6. V is x plus 1 squared, and v dash, by the chain rule, bring down the 2, multiply by the differential of x plus 1, which is 1, and then x plus 1 to 1 less power. So v dash is actually 2x plus 1. And then we would just use the quotient rule. Dy by dx is vu dash, subtract uv dash, all over v squared. Now substitute. Dy by dx is vu dash, so x plus 1 squared times u dash, which is 6x plus 6, which I'm going to write as 6 factorised out like that, so I'm going to write it as 6x plus 1 even, 6x plus 1. Subtract u, now u is this monster thing here, there's nothing I can do with that, 3x squared plus 6x subtract 7, and v dash is 2x plus 1. And all of this is going to be over v squared, and v is x plus 1 squared, so x plus 1 squared is as follows. Right, let's try and tidy up as best we can. Before we launch into timesing out here, think what factors could be factorised. What is in everything? An x plus 1 is in that factor and is in that factor. There's also a 2 in both of these. So it would be most sensible and help my life a hell of a lot if I factorised out a 2 and one of the x plus 1. That would leave me with a 3 and this x plus 1 squared. And it would also leave me with this subtract 3x squared plus 6x subtract 7 all over x plus 1 to the power of 4. Now the reason this helps so greatly is that x plus 1 cancels with one of those x plus 1s, and you'll have the x plus 1 cubed on the bottom, which is what you're after. Let's see if we can tidy up the top to make it equal to 20. So the 2's still there. If we expand this out here, x plus 1 squared multiplied by 3, so it would be 3x squared plus 2x plus 1, subtract, let's multiply out the minus 1 there. Subtract 3x squared, subtract 6x, and plus 7, all over x plus 1 cubed. And I'm fairly sure you can see we're getting there. This would give us 3x squared, would cancel with this 3x squared. Then we would get 6x cancelling with that 6x, and we get 3 plus 7, which is 10. So you would have 20 over x plus 1 cubed, and you have got the answer you were looking for. Okay, next one, it says show that the second derivative, hence find the second derivative and the real values for which d2y by dx squared is negative 15 over 4. So the first derivative, dy by dx, is equal to 20 over x plus 1 cubed. And you could write that as 20 x plus 1 to the negative 3. If we want to differentiate this one more time, we can use the chain rule, bring down the negative 3, multiply by the differential of the brackets, which is 1, and reduce the power of the expression in the brackets by an extra 1. And so this would give us negative 60 over x plus 1 to the power of 4. So that is our d2y over dx squared, and we have found it. And it asks us to find where this is equal to negative 15 over 4. So when is this equal to negative 15 over 4? First thing I'd probably do is divide both sides by the minus 1 to cancel the negative. Then I'd probably multiply by 4, and I'd multiply by x plus 1 to the power of 4. So my next line, I would get 60 times 4 over here, which is 240, would be equal to 15 x plus 1 to the power of 4. Then I would divide both sides by 15, so I would work out 240 divided by 15, so 240 divided by 15 is 16, so I would have x plus 1 to the power of 4 is equal to 16. If I take the fourth roots of this, I'm just going to swap this around. I'm just going to say x plus 1 to the 4 is equal to 16. If I take the fourth roots of this, x plus 1 is either equal to 2, or in fact x plus 1 could be negative 2, because 2 times 2 times 2 times 2 is 16, and negative 2 times negative 2 times negative 2 times negative 2 is 16. Don't forget this answer here. Many students will forget that one. Don't forget it. So therefore, x is equal to 1, subtracting 1 off both sides, and x is equal to negative 3. They are the real values of x for which this is true. Okay, next, we're differentiating the following with respect to x. I can do this all in one slide, I think. I think it's quite easy, this one. Let y be e to the, for part A, let y be e to the 3x plus ln of 2x. So differentiating dy by dx by the chain rule, you differentiate, remember if you differentiate, if y is equal to e to the f of x, then dy by dx is the differential of the exponent f dashed x, e to the same thing, e to the f of x. So this would be 3e to the 3x. Also remember that if you differentiate, if y is equal to ln f of x, then dy by dx is f dashed x over f of x, which would be equal to, the differential of this would be 2 over 2x. So tidying this up, dy by dx is therefore equal to 3e to the 3x plus 1 over x. Okay, so I'm going to rub this out here. I'm going to do part B. You should go down the page, but I'm just going to do it in a different coloured pen beside. If you let y is equal to 5 plus x squared to the 3 over 2, dy by dx, you can use the chain rule, bring down the 3 over 2, multiply by the differential of the brackets, which would be 2x, keep the brackets as it was, and reduce the power by 1. 3 over 2 take away 1 is a half. And just tidying that up, 3 over 2 times 2x would give me 3x, 5 plus x squared to the power of a half. And that is your dy by dx. Okay, next one. We want to differentiate the following two parts. So pause the video, have a go. I'll go through part 1 now. If that is your y, you want to find dy by dx, well, you should realise it's a quotient, it's a fraction, so it's of the form u over v. Your u is ln of x squared plus 1. Therefore, your u dash is the differential inside the ln, which is 2x over x squared plus 1, the actual function inside the ln. And your v is x, so your v dashed must be 1. Remember what the quotient rule says, dy by dx is vu dash, subtract uv dash, all over v squared. So substituting in here, dy by dx is therefore equal to vu dash, well, x times this, so it would be 2x squared over x squared plus 1, subtract uv dash, which would simply be ln of x squared plus 1, all divided by v squared, which is x squared. Now there's no need to tidy it up, it doesn't ask you to, but what you could do is you could realise that this is 1 over x squared times all this stuff, 1 over x squared times 2x squared over x squared plus 1, subtract ln of x squared plus 1, and then you could multiply the 1 over x squared into both. The x squareds would cancel in the first example and you would get as follows, and you would have subtract ln of x squared plus 1 over x squared. That would be your dy by dx in a tidier form, but I don't think there's anything wrong with leaving it like that. Okay, next. Okay, so moving on to the next one. It says that x is tan y, show that dy by dx is equal to this. Okay, this is a tricky question from, so let's give it a go. It's of the form x is equal to something, so x is the subject of the formula. So what we do in that case is we differentiate everything we see with respect to y. So dx by dy is the differential of tan y, which is sec squared y. And we know that dy by dx is 1 over this, okay? So we can flip it. So dy by dx must be 1 over sec squared y, okay? But at this point here, how are we going to get something like that? We've got the 1 over, but sec squared y is not in that form. Well, if you remember some of your identities, do you remember that sine squared, let's say y, plus cos squared y is equal to 1. So if you divided everything by cos squared y, you would get tan squared y plus 1 is equal, sorry, if you divided everything by cos squared y, you get tan squared y plus 1 is sec squared y. So you could replace sec squared y by 1 over 1 plus tan squared y. But look at your original up here. X is tan y, so tan squared y must be x squared, so that would be 1 over x squared. That is quite a tricky question there. And we're done on that example then. Okay, next one. Pause the video, have a go. Right, part A. Find the value of dy by dx at the point where x is 2 on the curve with this equation. So, hopefully again you're spotting it's of the form u times v, and your u is x squared, so your u dash will be 2x, and your v here you can't differentiate until it's in exponent form, would be 5x subtract 1 to the half. So v dash, bring down the half, multiplied by the differential of the brackets 5, and reduce the power of 5x minus 1 by 1, so. And we'd apply the product rule, so dy by dx is uv dash plus vu dash, and now we just substitute. So dy by by dx is uv dash x squared. Half times 5, I'm just going to say that's 5 over 2, 5x subtract 1 to the negative half, plus vu dash, so plus 5x subtract 1 to the positive half times u dash, which is 2x. Probably should give it a go at tidying up. Could factorise out, well, there's no real need actually, to be honest. You're just going to create a mistake for yourself. That should be acceptable in the mark scheme. I'll just check and see if that's right. Check, that is acceptable in the mark scheme. But you want to find dy by dx when x is equal to 2. So you write dy by dx when x is equal to 2. So what we're doing here, we're substituting in x is 2, so that would be 2 squared. It would be 5 over 2. 5 times 2 is 10, take away 1, so that would be 9 to the negative a half, plus, and this would be 9 to the positive a half times 4. 2 squared is 4. You can type this in your calculator. 9 to the negative half is 1 over the square root of 9, which is a third. So a third times 5 over 2 is 5 over 6. Type this in your calculator if you're not sure what I've done there, but I've done that in my head. 9 to the half is 3. 3 times 4 is 12. And so you've got yourself the following. 4 times 5 over 6, which is 20 over 6, plus 12. 20 over 6, that's 3 and a third, plus 12. So I think you get yourself 15 and a third. Okay, next, differentiate the following with respect to x. Again, you should be spotting this is a u divided by v. It's a quotient rule. There's your u, there's your v. U is sine 2x. U dashed is therefore 2 cos of 2x. V is x squared, and so v dashed is 2x. Always write down your quotient rule so it helps you remember it. So it's v u dashed minus uv dashed over v squared. And now substitute. So if y was your original function sine 2x over x squared, what's dy by dx? Well, dy by dx is vu dash, so x squared times 2 cos of 2x, subtract u of v dash, so sine 2x times 2x, all over v squared, which is x squared, which would be x to the power of 4. I think there is some tidying up we can do here. We could take out a factor of 2 and x. And we'd be left with, on the top, you'd be left with an x cos 2x. You'd be left with over here, subtract sine 2x, all over x to the 4. And that can be that x can be cancelled with one of those x's. And you would get yourself 2x cos 2x, subtract sine 2x, all divided by x cubed, and you'd be done. Okay, next, we're told to use the derivative of cosec x and cot x to prove the following. First things first, I'd write them down. They're in your formula booklet. If you differentiate cosec x, you get yourself negative cosec x cot x. And from your formula booklet, if you differentiate cot x, you get negative cosec squared x. These are in your formula booklet. You do not need to learn them. You are asked to use those results. Now, what you should know, however, is that if you've got a function y is ln of f of x, then dy by dx is the derivative inside the ln, f dashed x, over what was inside the ln normally, the function inside the ln. So on that note, we've got a ln of f of x, so dy by dx is the derivative of this, which is the sum of these two things here. So it's negative cosec x cot x, subtract cosec squared x all over the original function, which is cosec x plus cot x. Okay, doesn't look anything like this. But before you launch into anything complicated, substituting cosecs for cots and all this sort of thing, factorise. Just try and factorise. Watch what happens. Factorise out a negative. Factorise out a cosec. What would you be left with? Cot x plus cosec x all over cot x, or cot x, I've just put that first, plus cosec x. And hey presto, cancellation occurs and you get what you were looking for, namely negative cosec x. And it was a whole lot easier than it could have been if you hadn't factorised. Okay, next question. Here's your function. You're asked to show that f of x is equal to this. It's a 7 marker, so let's have a go. As I've always said with doing these, factorising is the absolute key. So f of x would be equal to, can't factorise that first fraction at all. Can you factorise this? No, but I'm just going to write it as 2x plus 9. I'm going to write it the other way around, and I'm going to try and factorise the bottom here into surely a 2x and an x, and it would be plus 2 here and negative 1 here. Okay, in order to subtract fractions, they have to have the same denominator. So this one's got an x plus 2 and this one has, but this one needs a 2x minus 1. So I would have 2x plus 3 over x plus 2. I would have multiplied the top and bottom here by 2x subtract 1. And I would have subtract 2x plus 9 over 2x. Well, I'll just write it in the same order here so it's obvious that the denominators are the same. X plus 2, 2x subtract 1. Okay, now they've got the same denominators, I can subtract them. So before I do that, let me just times this out. This would be 4x squared minus 2x plus 6x would be plus 4x subtract 3. Subtract everything in here, so it would be subtract 2x plus 9, keep your brackets there, all over x plus 2, 2x subtract 1. Okay, 4x squared, you've got plus 4x minus 2x, so it would be 4x squared plus 2x. You've got negative 3, subtract a 9, that would be negative 12. All over x plus 2, 2x subtract 1. Factorise out a 4, 4, sorry, not even a 4, you couldn't factorise out a 4 at all. What you could factorise out is a 2, so you'd factorise out a 2 and you'd get 2x squared plus x subtract 6 all over x plus 2, 2x subtract 1. Now I would like you to keep going down the page in your exam, but I'm running out of space, so I'm just going to go up here and continue the working here. Keep that 2 there and factorise this here. That would surely be a 2x and an x, and it would be plus 2 subtract 3, so it would be plus 2 there, subtract 3, all over x plus 2, 2x subtract 1. Oh, look what happens. That x plus 2 cancels with that x plus 2. The 2 can be times into this, and you would get 4x subtract 6 all over 2x subtract 1. That is exactly what you were asked to find in this question, and they are 7 marks, and that's quite straightforward. Okay, next part. It says, hence or otherwise, find f dash x in simplest form, the derivative. So f of x, there's no point differentiating this monster here. Differentiate this, it's much easier. Differentiate 4x minus 6 all over 2x subtract 1. 2x subtract 1. Get 3 marks here. It's of the form u over v. So we're going to use the quotient rule, u and v. U is 4x subtract 6, u dashed is 4, v is 2x subtract 1, v dash must be 2, dy by dx is therefore vu dash minus uv dash over v squared. And now all we've got to do is substitute in dy by dx, vu dash, so 2x minus 1 times 4, I'm going to put the 4 out the front, subtract uv dash, so I'm going to bring the 2 out the front for the v dash, and 4x subtract 6, all over v squared, which would be 2x subtract 1, all squared. If you multiply it out, you would get 8x subtract 4, and then subtract 8x, and then plus 12, all over 2x subtract 1 squared, and the 8x's cancel, and negative 4 at 12 is 8 over 2x subtract 1 all squared. And that is your dy by dx in its simplest form. Okay, next is a very similar question here. Express f of x as a fraction in its simplest form, hence differentiate. So let's have a go at part A. Again, factorising is the absolute key here. So f of x, can I factorise the top? Well, I could take a 2 out. That makes life a whole lot easier. Can I factorise the bottom? Well, I'm fairly sure that that's x subtract 3, x plus 1, and then subtract x plus 1 over x subtract 3. Now look what can happen here. These x plus 1s can go, and you've got yourself 2 over x subtract 3, subtract x plus 1 over x subtract 3. The denominators are the same, so you can subtract 2 subtract x. So this would be 2 subtract x subtract 1 all over x subtract 3, and that would be equal to 1 subtract x over x subtract 3. Do get into the habit here, f of x, any problems with f of x? Well, it can't be equal to 3. So that's your f of x. The next part was to differentiate the thing. So f of x was equal to 1 subtract x over x subtract 3. It's a quotient. It is of the form u divided by v. So u and v. Your u is 1 subtract x, your u dash is therefore minus 1. Your v is x subtract 3, so your v dash is therefore 1. The quotient rule says dy by dx is vu dash subtract uv dash all over v squared. So substituting in here, f dashed x is therefore vu dash, so x subtract 3 times negative 1, subtract uv dash, so 1 subtract x times 1, all divided by v squared, which would be x subtract 3 squared. Okay, times out this bracket, it would be negative x plus 3, and this here, if I times this out, it would be negative 1 plus x, all over x subtract 3 squared. Oh, look what happens, negative x cancel with a positive x, and we get ourselves what we were looking for in the question, namely 2 over x subtract 3 squared as your f dashed x. And you're done for another 3 marks. And finally, the last question we're going to do in these type of differentials is as follows. So pause the video, have a go. Right, let's go through each part bit by bit. Here's a function. Show that it is equal to this. Okay. F of x. In order to add these, the denominators have to be the same. So this one is really 1 over 1. It needs multiplying by x plus 2, x minus 2 on top and bottom. So x minus 2, plus 4 over x subtract 2, x plus 4. That's me dealing with that there. Then this one here, it's got an x plus 4 on the bottom, it needs an x subtract 2. So we take away, I need to multiply top and bottom by x subtract 2. So I've dealt with this one here. And the last one has the correct denominator. So x subtract 8 all over x subtract 2, x plus 4. So this one here is this one here. Now I can go ahead and tidy up the top. So let's multiply this out here. Be x squared plus 2x subtract 8. Subtract, if I multiply the 2 in, 2x subtract 4, and then plus 8 subtract, x subtract 8, all divided by x subtract 2, x plus 4. Okay, time for a bit of tidying up there on the top. I have an x squared plus 2x subtract 8, multiply the minus in both, subtract 2x plus 4, and then add the x and subtract the 8, all over x subtract 2, x plus 4. Okay, let's see what tidying up I can do. That 2x cancels with that negative 2x. And then you've got negative 8 plus 4 is negative 4, plus another negative 8 is negative 12. So you've got an x squared, you've got this still plus x, and you've got the negative 12 all over x subtract 2, x plus 4. This top factorizes into x plus 4, x subtract 3, all over x subtract 2, x plus 4. Oh look, we've got ourselves the x plus 4's cancelling, and we've got ourselves f of x is x minus 3 over x subtract 2 as required. Do write that final line, I just ran out of space. Okay, part B then says we've got a different function. G of x is this thing here. Differentiate g of x to show that this is true. Again, you should be familiar with this. That's a u over v. So that's u, that's v. So label your u is e to the x subtract 3, so that u dash would be just e to the x. V would be e to the x subtract 2, so v dash would be e to the x. The quotient rule says dy by dx is vu dash minus uv dash all over v squared. So substituting in to get your g dashed x or your dy by dx, vu dash e to the x subtract 2 times u dash, which is e to the x, minus uv dash e to the x subtract 3 multiplied by v dash, which is e to the x, all divided by v squared, which is e to the x minus 2 squared. And let's see if we can times this out. E to the x times e to the x is e to the 2x, subtract 2e to the x, minus e to the 2x plus 3e to the x, all over e to the x subtract 2 squared. And we're virtually there now, because that e to the 2x cancels with that e to the 2x. Negative e to the x plus 3e to the x is just e to the x over e to the x subtract 2 squared, and we've got what we're looking for. And last part of this whole thing here, find the values of x for which g dashed of x is equal to 1. G dashed x is e to the x over e to the x subtract 2 squared is equal to 1. Okay, times everything by e to the x minus 2 squared, so you get e to the x is e to the x subtract 2 squared. Multiply it out, what other choice do you have? E to the x minus 2, e to the x subtract 2, that's e to the x. E to the x times e to the x is e to the 2x, and that would be negative 4e to the x plus 4. Make one side 0, so it'd be e to the 2x subtract 5e to the x plus 4. This is a quadratic in disguise. It would be e to the x, e to the x. It would be subtract 1, subtract 4. So e to the x on one hand would be 4, e to the x on the other hand would be 1. Take luns of both sides, so x would be equal to ln 4, or x would be equal to ln of 1, and ln of 1 is equal to 0. So x is 0, or x is equal to ln of 4. And that is, they are all the questions that have come up in terms of simple differentiation where they just say differentiate a function. There'll be a differentiation 2 video where we look at all the differentiation used to find tangents and normals to curves, and there'll be a differentiation 3 video where we're asked to find turning points and maxima and minima. But hopefully you found that useful in your revision. Thank you for watching.